Consider the possibility of infinite versions of yourself existing in parallel universes. Have you ever observed the night sky, with stars scattered like diamonds on velvet, and experienced a profound sense of awe and wonder? The vast expanse above us, replete with innumerable stars, planets, and galaxies, has perpetually been a source of fascination and enigma. The universe, in its immensity, harbors countless mysteries, and perhaps none is as compelling as the concept of parallel universes. These are realms that coexist with our own, unseen and untouched, yet potentially just as real. Envision a reality where different choices were made, where every decision branched into a new path, creating a multitude of alternate realities. Where history unfolded in alternate ways, leading to worlds that are both familiar and alien. Or where the fundamental laws of physics might differ, giving rise to phenomena beyond our wildest imaginations. This is not merely the domain of science fiction, it is a concept that has taken root in theoretical physics, sparking debate and igniting imaginations globally. Scientists and theorists contemplate the implications of such realities, exploring the mathematical frameworks that might support them. The allure of parallel universes is undeniable. It captivates our intellect and emotions, drawing us into a world of endless possibilities. It speaks to our intrinsic curiosity about the nature of reality, the desire to comprehend what lies beyond the visible and the known. The possibilities that lie beyond our perception are vast and varied, each one a tantalizing glimpse into what could be. What if there are other versions of ourselves out there living different lives? Each choice we make, each path we take could lead to a different version of us, existing in a parallel universe. What if our universe is merely one bubble in a cosmic froth of countless universes, each with its own unique narrative? Each bubble could contain a universe with its own set of rules, histories, and destinies. The idea is both exhilarating and unsettling, challenging our understanding of existence itself. It compels us to rethink everything we know about reality and our place within it. The journey into the realm of parallel universes is a mind-bending one, taking us to the very edge of scientific understanding and pushing the boundaries of human imagination. It invites us to explore the unknown and to question the very fabric of reality. Exploring these cosmic mysteries necessitates a blend of scientific rigor and imaginative thinking. It is a dance between what we can prove and what we can dream. It is a journey that forces us to confront fundamental questions about our place in the cosmos and the nature of reality itself. Are we merely one of many, or is our universe unique in its existence? Are we prepared to embrace the possibility of a multiverse, a reality far grander and stranger than we ever imagined? The concept of a multiverse opens up a realm of infinite possibilities, each one more intriguing than the last. It challenges us to expand our minds and to consider the vastness of existence in a new light. The concept of parallel universes, while seemingly fantastical, finds its roots in scientific theories that seek to explain the workings of our own universe. These theories, though complex and often counterintuitive, provide a fascinating glimpse into the potential realities that might exist alongside our own. One such theory is quantum mechanics, which governs the behavior of matter at the subatomic level. Quantum mechanics has revolutionized our understanding of the microscopic world, revealing a realm where the rules of classical physics no longer apply. Quantum mechanics introduces the mind-boggling idea that particles don't exist in definite states, but rather in a superposition of possibilities, meaning they can be in multiple states at once until observed. This phenomenon, known as superposition, challenges our everyday experiences and intuitions about reality. This strange behavior gives rise to the many worlds interpretation of quantum mechanics, proposed by physicist Hugh Everett III in the 1950s. According to this interpretation, every possible outcome of a quantum event actually occurs, each in its own separate universe.
Everett's theory suggests that every time a quantum measurement is made, causing a particle superposition to collapse into a single state, the universe splits, creating a separate branch of reality for each possible outcome. This means that there are potentially countless versions of ourselves, each living in a different universe where different decisions and events have unfolded. In essence, every quantum event spawns a multitude of parallel universes, each representing a different path that reality could have taken. This idea, while difficult to grasp, opens up a vast and intriguing landscape of possibilities. Another avenue that leads to the concept of parallel universes is string theory. a framework in theoretical physics that attempts to reconcile quantum mechanics with Einstein's theory of general relativity. String theory aims to provide a unified description of all fundamental forces and particles in the universe. String theory proposes that the fundamental building blocks of the universe are not point-like particles, but tiny vibrating strings of energy. These strings are incredibly small, on the order of the Planck length, which is about 10 circumflex 35 meters. These strings vibrate at different frequencies, giving rise to the various particles and forces we observe in nature. Just as different musical notes are produced by different vibrations of a guitar string, different particles are thought to arise from different vibrational modes of these fundamental strings.
However, string theory requires the existence of extra spatial dimensions beyond the three we experience in our everyday lives. These additional dimensions are necessary for the mathematical consistency of the theory. These extra dimensions are thought to be curled up or compactified, too small to be detected directly. They are often visualized as being compactified into complex shapes, such as Calabi-Yau manifolds, which are six-dimensional spaces that can be folded in various ways. The intriguing aspect is that the way these extra dimensions are compactified could give rise to a vast number of possible universes, each with its own set of physical laws and constants. This means that the fundamental properties of our universe, such as the strength of gravity or the masses of elementary particles, could be different in other universes, leading to a rich and diverse multiverse. While the concept of parallel universes might seem like pure speculation, there are tantalizing hints from scientific experiments and observations that lend credence to the idea. The notion that our universe is not the only one but rather part of a vast multiverse has intrigued scientists and philosophers alike for decades. This idea, while still in the realm of theoretical physics, is gaining traction as more evidence comes to light. One such hint comes from the study of cosmic microwave background radiation, the faint afterglow of the Big Bang that permeates all of space. This radiation is like a snapshot of the early universe, providing a wealth of information about its origins and evolution. By analyzing this ancient light, scientists can uncover clues about the fundamental nature of our cosmos. Careful observations of this radiation have revealed subtle temperature fluctuations, suggesting that our universe might have interacted with other universes in the distant past. These fluctuations are not random but exhibit patterns that could be indicative of such interactions. The idea is that these interactions left behind traces, much like fingerprints, that we can detect and study. These interactions could have left imprints on the fabric of space-time, like ripples in a pond after a stone is thrown in. Just as ripples spread out and interact with each other, so too might the effects of these cosmic interactions be observed across the vast expanse of the universe. This concept opens up fascinating possibilities for understanding the true nature of reality. These anomalies in the cosmic microwave background radiation, while not conclusive proof, provide a tantalizing glimpse into the possibility of a multiverse. The idea that there could be countless other universes, each with its own unique properties and laws of physics, is both mind-boggling and exhilarating. It challenges our perception of reality and invites us to think beyond the confines of our own universe.
Furthermore, experiments in quantum mechanics continue to demonstrate the bizarre nature of the quantum world, where particles behave in ways that defy our classical understanding. Quantum mechanics, the branch of physics that deals with the smallest scales of energy levels of atoms and subatomic particles, reveals a universe that is far stranger than we could have ever imagined, where particles can tunnel through barriers, seemingly passing through solid objects as if they were not there. This phenomenon, known as quantum tunneling, has no counterpart in the macroscopic world we are familiar with. It suggests that the rules governing the quantum realm are fundamentally different from those that apply to our everyday experiences, exist in multiple states simultaneously, a concept known as superposition. In the quantum world, particles can be in multiple places or states at once, only settling into a single state when observed. This defies our classical intuition and suggests that reality at its most fundamental level is probabilistic rather than deterministic, and even become entangled, influencing each other instantaneously regardless of distance. This phenomenon, known as quantum entanglement, implies that particles can be connected in such a way that the state of one particle instantly affects the state of another, no matter how far apart they are. This spooky action at a distance, as Einstein called it, challenges our understanding of space and time. These phenomena, while well established in the laboratory, defy our classical intuitions about how reality should behave. They suggest that the universe operates on principles that are fundamentally different from those we experience in our everyday lives. This has profound implications for our understanding of the nature of reality and the potential existence of other universes. The fact that the universe operates on principles that seem so counterintuitive to our everyday experience leaves open the possibility that our understanding of reality is far from complete. It suggests that there may be aspects of the universe that we have yet to discover, and that our current theories are only scratching the surface of a much deeper and more complex reality. Perhaps the strange behavior of the quantum world is a hint that our universe is just one of many, interconnected in ways we are only beginning to grasp. The idea of a multiverse with countless other universes existing alongside our own, each with its own unique properties and laws of physics, is a tantalizing possibility that continues to inspire and challenge scientists and thinkers around the world. As we continue to explore the mysteries of the quantum world and the cosmos, we may one day uncover the true nature of reality and our place within it.
The concept of parallel universes isn't just a scientific curiosity. It's an idea that has captured the human imagination for centuries, finding expression in mythology, philosophy, and literature. From ancient Hindu cosmology with its cyclical universes to the philosophical musings of Gottfried Wilhelm Leibniz, who envisioned a best of all possible worlds, the idea of multiple realities has resonated with thinkers throughout history.
On a personal level, the concept of parallel universes can be both intriguing and unsettling. It begs the question, what if we had made different choices in our lives? What if we had taken that other job, moved to that other city, or married that other person? The idea of infinite possibilities, while exciting, can also be overwhelming. It forces us to confront the paths not taken, the lives we might have lived.
The existence of parallel universes also raises profound philosophical questions about identity and free will. If there are infinite versions of ourselves out there, making different choices and living different lives, does our sense of self become meaningless? Does free will have any significance in a multiverse where every possible outcome already exists in some parallel reality?